And then we're going to go on now, since it's going to be there. I'm going to do the words for the next day. So if you please follow along, we can have the new words up there. Word 10. And you've had these two words before. So this chapter is mostly repeat, but focusing on the space science. The first word in the next reading section is rotation. And remember, I gave you that little funny rule, rotations, the spinning of a body on its axis. So rotation is the spinning of the body on its axis. Look at the Latin. Rotare, rotavi, rotatum, to turn. And then revolutions is the motion of a body that travels around another in space, one complete trip along an orbit. So revolution, orbit, orbit, orbit. So rotation on axis, and revolution is an orbit around, in our case, around the sun. So we rotate on our axis every 24 hours. We revolve on orbit around the sun once a year. And then, if we are in an ellipse, and we told you we're not a perfect revolution around the sun. Sometimes we're closer, and sometimes we're further away. If you're perihelion, peri means near, and helios means sun. The point in the orbit of a planet in which it is closest to the sun. And that is 147 million kilometers from the Earth. And look at aphelion. That means you are away. The point in the orbit in the planet which is furthest from the sun, that is 152 million kilometers. Now, it looks, what happened? Okay, I think go back, Peter.
Yeah, sorry.
Can we just go on to the next words? We're up to word 14, please. Thank you very much. It's all right. You just have to go. This will be perfectly all right. So the next word after being the closest. Now remember, as I said, as you're going around the sun, and if I have this up here, and we'll say that the camera is the sun. And we're going around the sun in an orbit, and it takes us a whole year to go all the way around and come back from the other side. But we do turn on our axis. That's once every 24 hours. One complete turn. So rotate on axis, revolution around the sun in orbit. Now, we happens to be on word 14. You've had this word before, constellations. And I said you had to know some of the examples. So you have Ursa Major, Big Bear. Ursa Minor, which is Little Bear. Cygnus the Swan. Pegasus the Winged Horse. And I said, it's very interesting. We call this Ursa Major and Ursa Minor the Big Dipper and the Small Dipper. But those are just different names that people have given these constellations. So constellations is a group of stars organized and are recognizable. And notice I underlined that. I can't see a big bear when I look this. I can't see a minor bear, but these are what they would call recognizable patterns. But we can sort of see a Big Dipper and a Minor Dipper. Now, if we can have these kinds of rotations and these kinds of revolutions, you can then make a calendar. It's a system used to measure the passage of time. Greek kalende, account book, a system. So what system do we have? We have a day, dies, da, masculine, feminine, second, day, time of period. The time required for the Earth to make one rotation on its axis about 24 hours. And then you can add these days up, and we call it a month. From Old English, mona, meaning moon, month. The time required for the moon to go through one set of its phases as it orbits the Earth, about 29.5 days. Sometimes referred to as a synodic month. That's a word you don't have in your book, but I put it there, synodic month. Now, if you analyze that, 29.5 days, that means theoretically you could have 2 full moons in the same month. And we used to say that was once in a blue moon. You could have 2 full moons in the same month if some months have 31 days. Think about that. Next is solar year. Of course, you understand that from sol, solus, masculine sun, and German Jahr, to go. The time required for the Earth to make one orbit around the Sun, approximately 365.24 days. So that gives you a problem, doesn't it? A problem. What do you do with those extra funny days? 0.24. Well, you know now about every 4 years we add an extra day called leap year. Could we do the calendars, please? Put 19 on top if you can. Thank you, Peter. Very good. The Julian calendar is the one we're still following today with the modification of Pope Gregory the Great. So the Julian calendar from Julius Caesar, way back, a calendar devised by Julius Caesar's astronomers, consisted of 12 months, 11 with 30 days, or 31 days, and one with 28 days, and the extra day added every 4 years. Well, they didn't do that. We have to add that extra day, and that's what the Gregorian calendar was now. And it still didn't come out right, a year with an extra day and occurring every 4 years, except divided by an even number. So what happened? The Pope came along and found out, well, the spring was no longer on March 21st. It slipped, and the seasons were off. So he just issued for the Europe at that time was mostly Catholic. He just said we're dropping 14 days, and he just moved the calendar to get the seasons in line. And people were so upset they thought they had taken 14 days away from your life. Nonsense. It was just another way of making the calculation. The revision of the Julian calendar, currently used by most of the world, actually. I mean, there is the Chinese calendar, of course, is very big. You have the Jewish calendars, is very important. Now, people decided we don't like this stupid leap years. Why can't we even these out? Well, they made some artificial calendars. One is called the world calendar, another the 13-month calendar, and look at how difficult these are. 13 months. Each month would have 28 days, and a new month called Sol would be added between June and July. One day called year day, belonging to no week or month, would be added at each year, at the end of each year. Every 4 years, a leap year day would be added at the end of Sol. Well, no one accepted that one. Another one came along was the world calendar. The calendar of 12 months of either 30 or 31 days. A world day would be added at the end of each year. A leap year day would be added at the end of June.